There is a devastating security vulnerability that was discovered in the OpenSSL implementation of the SSL/TLS protocol. And if you don't know, TLS is the protocol that is commonly used to safeguard transactions you might make on the web. Sometimes you hear TLS referred to as SSL and vice versa. Technically, SSL is a protocol that came first. TLS is kind of a successor, more or less, to SSL, but for the purpose of this video, you can more or less think of them as being interchangeable. So for example, when you see the letters HTTPS in your web browser, typically you'll see that next to a lock icon. It means that the web page that you're viewing has been transmitted to you in encrypted form. And in particular, that means that your data is supposed to be safeguarded from any type of eavesdropping or prying eyes. And that actually goes both ways in this case. So any passwords you type in, any confidential data you provide to that website will in theory be encrypted and be safe from somebody trying to eavesdrop on it. And in particular, what the S means in the context of HTTPS is that you are transmitting web traffic or HTTP traffic, but it's encrypted using SSL. OpenSSL is actually just one implementation of the TLS protocol, but it also happens to be the most widely deployed implementation. If you use the web with any degree of frequency, there is pretty much a 100% chance you have interacted with an OpenSSL implementation, even though you might have not otherwise known it. Now, in version 1.0.1 and also in some of the beta releases of version 1.0.2, there is a subtle but highly critical programming mistake that can lead to an attacker learning your confidential data. And a system that's running these vulnerable versions of SSL, or in particular these vulnerable versions of OpenSSL, can be attacked quite easily. And what I'll do in this video is I'm going to describe both the attack and the flaw it exploits at a high level, and I'll also talk about some of its ramifications. And in particular, there is an extension to the TLS protocol known as the heartbeat. And what the heartbeat extension allows you to do is keep a TLS session up and running even though no real data has gone through it in a while, by simply sending a special message known as a heartbeat request. Now this is useful because before this heartbeat idea existed, before this heartbeat extension, if there was some temporary gap or lapse in data going between a client and the server for some, let's say, defined period of time, then the TLS session might have terminated during that time, and it would need to be reestablished, and that takes a bit of effort. The heartbeat extension is also useful if you want to find out whether the peer with whom you're communicating is still there. If you send a heartbeat request to that peer, you can basically keep the session alive, kind of keep it warm, if you will. And you also get to find out if the computer to whom the request was sent is still there, because that computer has to respond back to that request. And by virtue of seeing the response, you can ensure that the computer is kind of there, the session is still alive, so to speak. So the heartbeat request is sent by one computer to another, and the request basically contains some request data, and that data includes a payload, and it also includes some explicit information that specifies the size of that payload. The computer that's responding to a heartbeat request will actually contain, in its response, this same payload information, and also a little bit of other padding. Now the way the attack works is that the attacker will craft a special heartbeat request, and this request will contain a little bit of data, and this data associated with the request will also contain inside of it information about how much data is in the request, the ostensible size of that request. Now the attacker can actually craft this request any way he wants, and what he's actually going to do is something very malicious. He's going to craft this request in a very malicious fashion. The attacker will send a payload that's actually very short. Imagine it's just 1 byte in length. But instead of saying the payload is just 1 byte, the attacker will lie and say, hey, this payload is actually 65,536 bytes. Now the code that handles the heartbeat extension piece within the OpenSSL library actually will copy this payload that the attacker provided into its memory, and then at some point, as part of the response, it's going to copy this data back out from its memory and send back a heartbeat response to the attacker. However, rather than checking what the actual size of the payload itself happened to actually be, the OpenSSL heartbeat code just uses the value specified in the request. And this is a mistake. Instead of verifying that the actual size is consistent with what the requester put in, OpenSSL simply blindly uses the value that was included with the request. But this value could be bogus. It could be completely wrong. So now let's see what happens if the attacker only provides a 1 byte payload, but says that the size is 65,536 bytes. In this case, OpenSSL will locate the starting location, where it stored the payload in its memory, and then it's going to copy the next 65,536 bytes as part of the response. The first byte is the actual payload that the attacker specified in his request. But what are these other remaining 65,535 bytes? Well, these remaining 65,535 bytes are just the bytes that were stored in the memory of OpenSSL. And in total, these 65,536 bytes get returned back to the attacker that initiated the heartbeat request as part of that response that he's going to receive from the OpenSSL heartbeat code. But now suddenly the attacker sees an additional 65,535 bytes that were stored in the memory of OpenSSL. And these 65,535 additional bytes are not the ones he should have been otherwise able to see. Now keep in mind that OpenSSL is meant to provide security for sensitive data. And what that means is that it might have in its memory a lot of sensitive data that it was processing. It turns out that this sensitive data could include things like your confidential data, your password. Even worse, it could contain things like the keys that SSL was using to encrypt and decrypt data going back and forth to you. And if an attacker has these keys, he can not only decipher any further traffic, but if he has a record of any past encrypted traffic, maybe he somehow recorded it in the past, he can try to read that as well now that he's armed with this knowledge of the decryption keys. Now there actually is another safeguard built into SSL known as perfect forward secrecy, and if perfect forward secrecy is enabled, and by the way, not everybody enables it, but if it's enabled, then you can mitigate the risk of past traffic being compromised. But that said, even if an attacker gets sensitive information about the current session, they can get access to data that you thought was encrypted and whose confidentiality you thought was being maintained, and that can potentially be extremely dangerous. It's also worth noting the attacker can repeat this attack multiple times and get different sets of bytes from memory as well. So it is a very potent attack in that regard. What's even worse, and I think it's worth stressing, is that the way the implementation is today, an attacker can carry out this attack without leaving so much as a trace. Now, I haven't actually heard of someone trying to exploit the security flaw so far, but remember, because an attack can be done without leaving a trace, it is entirely possible that someone has been doing it all along and we just don't even know about it. So hopefully this video provided you with an indication regarding both the severity and also the high-level mechanics of the security flaw. If you are running a web server with OpenSSL, I would urge you to learn more about this vulnerability. There's a website out there, and I'll give you the address, www.heartbleed.com, that has just a wealth of additional technical data about this flaw, and you should consider checking it out and trying to learn more about this vulnerability.